Welcome to the Explainer. Okay, let's dive into this. Today, we're unpacking Domain 5 of the ISC2 Certified in Cybersecurity exam, and that is all about security operations. But honestly, rather than just reading through a dry list of terms, we're going to visualize this whole domain as a series of concentric rings of defense. It's like a giant puzzle. We'll start at the very center, your absolutely most sensitive data, and work our way outward, all the way to the actual human beings operating the systems.
So, here's our roadmap. We'll start with data security and cryptography, expand out to system hardening, followed by SIEM and security logging, and finally wrap up with building a human firewall.
But before we get completely lost in the technical weeds, let's ground this theory in reality. What does a cybersecurity professional actually do all day? Well, imagine the shift of a security operations center or SOC analyst. They aren't just sitting in a dark room, staring at green code, falling down a black screen like in some Hollywood movie. Right? They're actively maintaining the hygiene of the organization. They're out there monitoring alerts, managing vulnerabilities, ensuring patches are applied, and verifying that policies are actually being followed. It's the day-to-day operational heartbeat of keeping an organization secure.
And you know, that operational heartbeat represents a massive chunk of your foundational knowledge. Security operations makes up 18% of the entire CCE exam, literally one of the largest domains you'll face. And why is that? Because while theory and architecture are great, this 18% represents the absolutely crucial daily tasks that keep the lights on and the attackers out.
Okay, Section 1, Data Security and Cryptography. Let's protect the data.
This perfectly illustrates the two primary ways we protect data confidentiality: symmetric and asymmetric encryption. Now think of symmetric encryption like a traditional safe with one specific physical key. You use that exact same key to lock it and unlock it. Because it's a single shared key, it is lightning fast, but it's incredibly hard to scale securely. Like, how do you safely mail that one physical key to 1,000 different people? You don't. That's where asymmetric encryption steps in. It utilizes a public and private key pair. Imagine a safe where anyone, literally anyone, can drop a message inside using a publicly available padlock, but only you hold the private unique key to actually open the safe and read the contents. So it's highly scalable. It completely solves that key exchange problem, but it is computationally much more expensive.
Now, while encryption protects confidentiality, hashing is all about integrity. Hashing takes a file, doesn't matter how big or small, and runs it through a one-way mathematical function to produce a fixed-sized, completely unique string of characters. Think of it as an unbreakable digital fingerprint. If even a single comma is changed in a massive document, the resulting hash will be completely different. And it's absolutely crucial to remember that hashing is one way. You cannot reverse engineer the original file from the hash. No way. It is strictly used to verify that the data hasn't been tampered with.
Of course, data doesn't live forever. Security operations dictates how we handle data from birth to death. We start with classification, so labeling data based on its sensitivity. Then we have retention policies, which dictate exactly how long we're legally or operationally required to keep it around. And finally, destruction. Look, when it's time to destroy data, you can't just drag it to the recycle bin and call it a day. We use methods like degaussing, which uses a massive magnetic field to totally disrupt the magnetic domains on a hard drive, erasing the data. But, and here's a fun fact, degaussing is famously ineffective on modern solid-state drives, or SSDs. For those, you often have to rely on good old-fashioned physical destruction. We're talking literally shredding the drives into tiny metal pieces.
Moving on to Section 2, System Hardening, Securing the Infrastructure. System hardening is fundamentally about reducing your attack surface. Imagine buying a brand new house, but for some reason it comes with 50 doors and 100 windows you're never, ever going to use. Hardening is the process of bricking up those unnecessary doors and windows so you only have to guard the front door. Step 1 is establishing secure baselines, creating a standardized template so every server starts with a minimum level of security. Step 2 is removing unused software and services, basically disabling protocols you just don't need. And Step 3 is rigorously applying security updates and patches to fix known vulnerabilities. But you know, hardening isn't just about technical configurations. It heavily relies on strict operational policies. I mean, your baseline won't hold up for a second if employees are plugging in infected personal devices. That's exactly why we have the Acceptable Use Policy, or AUP, defining what behavior is actually permitted on company equipment. We also have Bring Your Own Device, or BYOD policies. A really strong BYOD policy is essential to mitigate what we call shadow IT, which is when employees decide to use unvetted, unmanaged personal devices or software for work. Finally, change management. Any change to a hardened system has to be documented, approved, and tested. Why? Because a single untested change can accidentally open up a massive security gap.
All right, Section 3, SIEM and security logging. Time for active monitoring.
So the crucial takeaway here is that every single device on your network is constantly generating log data. Firewalls are logging network traffic and blocking external threats. Endpoints, like employee laptops, are logging device activity and detecting local malware. Servers are logging system access and spotting unauthorized logins. In a modern enterprise, this generates an absolutely overwhelming amount of data. It's the digital equivalent of asking a single security guard to watch 1,000 CCTV monitors at the exact same time. It's literally impossible for a human to process.
Now, what's really interesting about this is how we actually solve that overwhelming problem. The solution is the SIEM, or Security Information and Event Management System. This piece of software is the absolute hero of the Security Operations Center.
A SIEM takes all those thousands of chaotic CCTV feeds and acts as your brilliant automated assistant. First, it aggregates all those disparate logs into a single pane of glass. Then, modern SIEMs use artificial intelligence and machine learning to actually correlate these events. They identify weird behavioral anomalies, like impossible travel. A situation where a user logs in from New York and then somehow 10 minutes later logs in from Tokyo. By doing all that heavy lifting, the SIEM flashes a red box only when someone is actually picking a lock. It effectively cures alert fatigue for our SOC analysts, allowing them to focus on real threats instead of just drowning in a sea of benign log data.
Which brings us to our final ring, Section 4, building a human firewall. The outermost perimeter.
I absolutely love this quote. Effective training turns employees into a human firewall. Think about it. We spend millions of dollars on highly technical, automated firewalls. But if an attacker can just pick up the phone, pretend to be IT, and ask an employee for their password, well, all those millions of dollars are bypassed in seconds. Psychological security awareness training is what actually defends this human element.
The threats to this human perimeter are constant, and they're evolving. We have social engineering and phishing, tricking users into handing over credentials. We have physical threats like tailgating and piggybacking, where an unauthorized person simply walks right behind an employee through a secured door. We have weak password hygiene. And importantly, we have very modern risks like data leakage via public AI LLMs. Imagine an employee trying to be productive, so they copy and paste highly sensitive proprietary source code into a public AI chatbot just to ask it to fix a bug, accidentally leaking company secrets to the entire world. A well-trained human firewall recognizes these risks and stops them cold.
We've covered a ton of ground today, moving all the way from the mathematical certainty of data hashing right out to the psychological complexities of the human perimeter. So I want to leave you with a final thought to apply to your own environment. Looking at these concentric rings, data, systems, logging, and humans, which operational layer is your organization's weakest link? Assess your environment, apply this framework, and we'll see you in the next explainer.